So in task 3, you're supposed to set it up so that the motor here does 10 360-degree rotations. Now, in order to measure those rotations, what we do is we put a couple of these blue pins in a long arm like this, so it's kind of like the hand on an analog clock. And then when this comes by the motor here, we want to make sure that it's not hitting there. So what we suggest you do is pull out these pins a little bit. So basically you have an arm. And in order to do this, you're going to rotate your arm. Basically the arm rotates this way. So we're going to rotate the arm back until it is right about even with the edge of the brick, that way, or the edge of the motor, so that we know where it is starting at. Then we're going to go ahead and let it do 10 rotations. Now after it's done 10 rotations, we happen to have a protractor, and we're going to set the protractor on here. And I think under the camera you can kind of see that we're lined up with the center and then with essentially 0 degrees, and then this protractor, it looks like we're off by about 10, maybe 11 degrees. Now for students, it's real common that you can just go on Google and put in the word protractor, and it'll bring up an example of a protractor, and they can just hold the motor up against the computer screen because you may not have protractors. Now we're going to start a table here, and we're going to say this was trial number 1, and on trial number 1 our start was at 0 degrees and our end was at 11 degrees. So the difference, or the change, is 11 degrees. So now we want to do 10 trials with this, and so I'm going to run this back and get it to start right at the beginning. You'll notice that there's a little bit of gear slop in these motors are a toy. And then we're going to go ahead and run this so it goes around 10 times. This is our trial number 2. And on trial number 2, the difference between the start and the end spot is probably about 15 degrees. So on this one, we're going to, number 2, we're going to start at 0 degrees. Our end will be 15 degrees, and the change is then 15 degrees. Now we're going to pull this back and do another trial. This is trial number 3. And on trial number 3, we're going to take a look here. And try to set this up, and it's probably about 12 degrees. Number 3. We're collecting our data and writing down all of our data. Now, we're going to do 10 trials, obviously, on this, using the motor. And on this motor, we've got it set at 75% for our power. And we're going to create a bar graph that shows what we're doing. So in order to create that bar graph, we're going to make a line here, and we're going to go ahead and make a line down here. And with any kind of a graph, you always want to label what you're doing. And so this axis is going to be degrees. And we're going to start here with 0, 1, 2, 3, 4, that's 5 degrees, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 degrees. And then here on the bottom of the graph, this is going to be our trial. And our first trial will be number 1 here. And on trial number 1, we said that our difference was 11 degrees. So that would be right about here. I'm going to put a little 11 on that. I'm going to create kind of a bar graph to represent this. And fill it in with some dashes there. And then on trial number 2, we said that our difference was 15 degrees, which would be up here. fill that in. And trial number 3, we said is 12 degrees. And then, of course, you're going to continue to do your trials. Now, anytime you do a graph, of course, you want to label your axes, which we've done, but we also want to put a title on this graph. And our title here is going to be change in degrees for 10 360-degree rotations. Now you also, of course, want to put your name on the graph, and you want to put the date on the graph. Now we might want to do some additional tests, and we might want to put a little key in here someplace and say that our tests, where it looks like this, that was a 75% power level. So the power level may make a difference on the accuracy on this. Whenever you're going to use multiple motors in an application, like 2 motors that try to drive the robot forward, it's always good if you can test your motors and make sure that you've got motors that pretty much match. And this is one of the ways that you can go in and test those motors and see if they match. This is also a good idea of a way to get to know your motors, because different motors, depending upon what's happened to them in the past, may not perform as consistently as other motors. And when you're trying to get accuracy, it's good to know how your motors are responding.